Hello YouTubers. I brought my California hat because if there's one thing all Portlanders can agree on, it's our mutual admiration of all things California. Welcome to episode 4. This is the story of Bobby and Sally at Catlandia. Bobby and Sally. They're looking to buy a cat, and the problem is checkout is a little slow at Catlandia. With an orange cat, they're going to have to wait 1 minute for checkout of the first cat in line in front of them. Then 3 times as long afterwards, so that's 3 more minutes. And then after that, 3 times as long again, so 3 times 3, which is 9. And then the next cat is going to take 27 minutes to check out. Definitely slowing down considerably. There are 100 cats in all, so if we think of these as powers of 3, 1 plus 3 to the first power, plus 3 to the second power, plus 3 to the third power. Can you see that all right? We're going to go up to 3 to the 99th power. And this is how many minutes Bobby and Sally are going to have to wait to purchase Mr. Whiskers in the orange cat line. So how many minutes is that? Well, let's call this T for time. T equals, okay? I'm going to do a little trick. So here I have a regular top hat, and what's this? Oh, hello, Mr. Bunny. No, not that trick. Okay. We have this sum. By the way, if you're taking notes at home, this is usually called a geometric series. So, watch this. If we took 3 times the amount of time, why would we do that? Well, I'll show you. Then 1 times 3 would be 3. 3 times 3 would be 9. 9 times 3 would be 27. Oh, look at this. It's starting to look like the original series, except everything is shifted over 1. So we're going to end up with 3 to the 99th, but then we're going to have one more term, 3 to the 100th power. Okay? And now, if we take this one, and we look at their difference. So 3t subtract 1t, so that's 2t. We're going to be taking this big sum and subtracting this big sum. But pretty much everything in this sum appears again here, so they cancel each other out, except the largest term over there, which was 3 to the 100th power, and the smallest term here. So we end up with this number. So t is half of 3 to the 100th power subtract 1. Okay, and now that's a really big number. Approximately 2.6 times 10 to the 47th. Okay, so that's like a 48-digit number. That's how many minutes they're going to have to wait in the orange cat line. And so I was wondering, all right, with that many minutes, wouldn't we use a larger unit of time than minutes? So let's see what that looks like. So here we are. I wonder, let's see, minutes. If we take 60 minutes, we get an hour. And if we take 24 hours, we get a day. And if we take 365, but really 0.24, okay, this is what accounts for leap years. That's the days in a year. Then what we get here is 525,945.6. 525,945.6. Hey, that's got a nice little rhythm to it. Someone should make a song about that. Anyway, that's how many minutes we get in a year. So we could divide this enormous number, 2.6 times 10 to the 47th, by this, and we could convert this number of minutes into about 5 times 10 to the 41st years. Now, to say that that's a long time is an understatement. This is the estimate for the age of the universe is on the order of 10 to the 9th years. So this is significantly longer time than the length of the universe. By the way, in the black cat line, so this, by the way, this was all in the orange cat line, where we ended up with this truly enormous number of minutes. In the black cat line, we end up with 1.6 times 10 to the 60th minutes. Far larger. Answering Bruce's original question, we should definitely wait in the orange cat line. However, this amount of time is so long that assuming certain things about cosmology, we're talking about the heat death of the universe and everything drifting apart from everything else and dropping asymptotically towards absolute zero in temperature and everything going dark. So I'd like to dedicate episode 4 to one of my favorite words, nihilism. Join us next time on YouTube.